Solving quadratic equations using the quadratic formula. Any quadratic equation in standard form can be solved through the use of the quadratic formula. So if ax squared plus bx plus c is equal to 0, then the solutions of the equation are given by x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. This formula should probably be committed to memory. So here's an example. Suppose we are asked to solve the equation 3x squared minus 14x plus 11 is equal to 0. Notice that this equation is quadratic, and it is written in that standard form, with a equal to 3, b equal to negative 14, and c equal to 11. Then, applying the quadratic formula, the solutions would be given by x is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Notice that when I made those substitutions, I put all of those substitutions in parentheses to help me keep track of sign issues and to remember that on the right, under the radical, that there's some multiplications. Alright, so now we begin to simplify. The opposite of negative 14 is 14, plus or minus the square root of negative 14 times negative 14 is 196, minus 4 times 3 is 12, times 11 is 132, divided by 2 times 3, which is 6. Continuing our simplification under the radical, we would have 14 plus or minus the square root of, now 196 minus 132 is 64, divided by 6. And the square root of 64 is 8, so we can write that as 14 plus or minus 8 over 6. Now what I'll do is split this up into two numbers, right? Remember that plus or minus means that we have two values here. So I'll say x1, our first solution, is 14 minus 8 over 6, which is 6 over 6, which is 1. x2, our second solution, would be 14 plus 8 over 6, which is 22 over 6, or 11/3. And so our solution set for the equation contains 1 and 11/3. Here's the second example, 3x squared minus 12x plus 8 equals 0. Again, notice that this equation is in the standard form, and it is quadratic, with a equal to 3, b equal to negative 12, and c equal to 8. Using the quadratic formula, x would be the opposite of negative 12, plus or minus the square root of negative 12 squared minus 4 by 3 by 8, all divided by 2 times 3. The opposite of negative 12 is 12, plus or minus negative 12 squared is 144, minus 4 times 3 times 8, 4 times 3 is 12, 12 times 8 is 96, and 2 times 3 is 6. 12 plus or minus the square root, now 144 minus 96 is 48, and that's divided by 6. Now, unlike the previous exercise, 48 is not a perfect square, and so its square root is not a nice number. It's not rational. But we can still simplify this radical. And now here's where you should really look at the examples that you've seen in your class. Some instructors are perfectly happy with leaving your exact result in this form. Other instructors want you to take this out to a more simplified form. So, a little bit of side work here. Noticing that 48, the square root of 48, well, 48 is 16 times 3, and so that would be 4 times the square root of 3. So we now have 12 plus or minus 4 times the square root of 3 over 6. Now from here, notice that all three of the terms, the 12, the 4 times the square root of 3, and the 6 are all divisible by 2. Since we have that situation, we can divide out, we can factor out that common factor of 2 from each of the terms. So really what's happening here is I can think of this as 2 times 6 plus or minus 2 root 3 over 2 times 3, and then I can remove that common factor of 2, leaving 6 plus or minus 2 times the square root of 3 over 3. So now what I would do is just write that as a solution set. So the solution set would contain 6 minus 2 root 3 over 3 and 6 plus 2 root 3 over 3. Your instructor might ask for approximations of these solutions, in which case use your calculator to calculate those appropriately. Solve 2m squared minus 7m minus 13 is equal to negative 10. Alright, so notice that this equation is quadratic. We see that m squared, but it's not in the standard form. Well, we can easily put this in standard form by adding 10 to both sides. So we'll rewrite the equation as 2m squared minus 7m minus 3 is equal to 0. Now that the equation is in standard form, we can apply the quadratic formula. So m would equal the opposite of negative 7 plus or minus the square root of negative 7 squared minus 4 by 2 by negative 3, all divided by 2 times 2. Simplifying yields 7 plus or minus the square root of 49. Now here we have to be careful. We would have minus 4 times 2 is 8 times negative 3 is a negative 24. So we have 4 minus negative 24 under the radical. And we'd have a 4 in the denominator. So now remembering that when we subtract a negative, that's the same as adding a positive, we would have m equals 7 plus or minus the square root of 73 over 4. So 7 plus or minus the square root of 73 over 4. But there's nothing we can do here. 73 is not a perfect square, and in fact 73 is a prime number, so we cannot simplify the radical. So all we can do here is write this in its as a solution set. 7 minus the square root of 73 over 4, comma 7 plus the square root of 73 over 4. One more exercise. Here we are asked to solve 2x squared minus 2x plus 11 is equal to 0. Well, this is quadratic, and it's in standard form, so let's apply the quadratic formula. So x would equal the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 by 2 by 11, all divided by 2 times 2. Simplifying gives us 2 plus or minus the square root of 4 minus, now 4 times 2 is 8, times 11 is 88. So we have 4 minus 88 under the radical, and we have 2 times 2, which is 4 in the denominator. Now be careful here. Simplifying under the radical, 4 minus 88, this gives us 2 plus or minus the square root of negative 84 over 4. Now, the square root of negative 84 is not a real number. So at this point, we can say that there are no real solutions. And that might be all that your instructor wants. It depends on your instructor. Some instructors would want you to take this further and write the complex solutions of the equation. So read the instructions carefully, understand what your instructor wants. The square root of negative 84, recall that we can think of that negative 84, let's do a little work here on the side, negative 84, the square root of it. Well, notice that 84 is not a perfect square, but it has a perfect square factor of 4. So I'm going to think of that as the square root of 4 by 21 by negative 1. And I can break that up as the square root of 4 times the square root of 21 times the square root of negative 1, which can simplify as 2 square root 21. And remember, we can replace the square root of negative 1 with the symbol I, the imaginary unit. So, I have 2 plus or minus 2 square root 21 I over 4. But complex numbers are always written in the standard form. The standard form of a complex number is a plus bi. So let's break this up as 2/4 plus or minus 2 square root 21 over 4 I, and then we should notice, well, wait a second, I can reduce those fractions. 2 over 4 is 1/2 plus or minus, and 2 root 21 over 4, I can reduce between the 2 and the 4, leaving a root 21 over 2 I. And then writing my solution set, I'd have 1/2 minus root 21 over 2 I, comma, 1/2 plus root 21 over 2 I.